My name is Isabel, and I'm a solutions architect with a background in applied AI research, working with startups and scale-ups in Australia. In my role, I do my best to enable startups to be successful in the early days by prioritizing MVPs and agility along their journey as they grow and scale up. One part of having a forward-looking strategy is to stay up to date with and maybe even a little bit ahead of current trends and technologies, like machine learning. And that can lead to having to navigate a number of seemingly contradicting priorities. So today, I want to take you through some simple steps that will help you get and stay ready for machine learning while keeping an eye on skills, time, and the funds that are available in your startup. We'll have a look at reasons why we should care about this, what data to prioritize, how to set up cheap and ML-ready data repositories, but also look at when we might want to use alternative solutions. Okay, let's go on a startup journey. What are the most important things right now? We need a compelling story that can attract some initial customers, which hopefully leads to funding. Funding can help build MVPs. We want to stay nimble and we want to find a good market fit, which means being open to reinventing ourselves constantly. All right, we've got that. Now it's time to have a look at the team. Do we have all the skills we need? We also want to make sure that we maintain a good and sustainable culture in our startup. Now that that's all sorted, let's get some sleep. So we're lying in bed and browsing the internet and we find all these articles talking about machine learning. We have enough to do. Should we really care about this? And should we care about this now? Chances are that unless you see yourself as an ML startup, machine learning is not on the top of the list of your priorities right now. Things even seem to work against planning and implementing machine learning. This is the time to stay agile. Everything can change. Our financial situation, what data we're collecting, our customers, and even our team. We also know that building data pipelines and storing data costs money, something we might not have at this stage. Also, machine learning and data science require particular skills, but clearly now is not the time to hire for this. So with all that being said, what are the arguments for caring about machine learning at such an early stage? Well, some of the most successful startups and once startups really accelerated their growth by implementing machine learning. Even companies that on the face don't look like ML companies, like Netflix, a platform that allows you to watch movies, Duolingo, a tool that you can use to learn a new language, or the rideshare company Lyft. If a video, a learning, and a rideshare company use artificial intelligence, maybe we should take this seriously. And maybe there are ways in which machine learning can accelerate our success in ways we can't even imagine yet. I'll get back to these three later. Now, how exactly can machine learning help? We've got our application or service online. We collect some data. This can be user data or internal workflow data. We analyze that data to generate insights. And this is really where the machine learning magic happens. And those insights can help us make better decisions and improve our services in an almost unlimited number of ways. That makes our users happy, we get more data, better insights, better service. You get the picture. Let me label these steps. We start with data collection and engineering. We then have data science to generate insights, and machine learning operations that allow us to continuously integrate insights and update our application. And if you're interested in more detail on these topics, we have a data engineering and data science stream in our summit as well, so make sure to check those out. Okay, this feedback mechanism looks great. However, this doesn't start automatically. Collecting enough data to start with machine learning takes time. This is especially true right now, when we start with only a small number of customers and data points. So what happens if we don't capture our data early is that we miss out on the entire feedback loop. We are delaying the start of this entire process for what can potentially be years. So today I want to concentrate on this bit, the data collection part, and also a little bit of data engineering. We need to make sure that the moment we can and want to use AI, our available data is relevant, in a good shape, and large enough to hit the ground running. And there are some easy and cheap steps we can take to make sure that we don't lose any of our most valuable data. Now we know where we want to go. Let's get ourselves ready. And we'll keep in mind our limited resources, time, money, and available skills. First, to get us all on the same page, we'll start off with just enough AI to be able to understand what questions machine learning can answer. And I'll promise to keep this short and focused on the data aspect. After that, we'll have a closer look at what data we will encounter and how we can triage it. This means we will decide which data we'll prioritize, what we'll store for later, and what data we can safely toss out. And for each of these categories, we'll talk about some easy steps that will get the best of our data later on. To wrap the session up, I'll show you where we're headed given the current state of tools and services. This will put earlier recommendations in a better context and give you an idea of what will be possible in the long run. So let's dive right in. On the highest level, when we talk about AI, we come across 4 different types. And while I'm talking about them, try to keep in the back of your mind how humans learn, because you will find that this is quite similar. We can tell a computer what to do explicitly. We would do that by writing if-then statements. We can provide the computer with examples to learn from. We can ask it to do its best to group similar things together autonomously. And lastly, we can ask our programs to learn by doing. In the AI/ML world, these 4 are called rule-based AI, supervised machine learning, unsupervised machine learning, and reinforcement learning. And what way we go there really has implications on the data we need. For rule-based AI, since there is no automatic learning involved, we don't really need any data to get started. This relies on the knowledge of the programmer or experts around them. And as I said, any if-then statement falls into this category. Supervised machine learning needs data with labels. An example are images of animals together with a label or a tag of which animal is in which picture. Or movie descriptions where a user has told us if they liked or didn't like a film. Unsupervised learning also needs data, but this time we don't provide those labels and we'll let the computer figure out what similar data looks like. Maybe we want to segment customers based on their shopping behavior, so we'll let a program work out what the best segmentation looks like. And while this might be along lines that we have explicit data on, like gender or age, maybe what we find instead is that a better way of segmenting our customers is to split them into cat and dog people simply based on their shopping history. Lastly, there's reinforcement learning, which requires real-time feedback on what success and failure look like. This is often done through simulations, which takes time and money to implement well. So when it comes to our data right now, all we have to concern ourselves with are supervised and unsupervised machine learning. And the data for this can be anything from media data over textual data, tables, spreadsheets, and even network graphs. The data doesn't even need to be structured. Text, for example, is often not. Regardless of its type, the best data for machine learning is usually large, labeled and clean, or at least consistent. How large is large will depend on the task, so that's tricky to talk about in general terms, but I will dive into the 2 other points a little bit later on. Once we have the data, what are some things that machine learning has successfully been used for? Some things with which AI can help us are classification, like is this a romantic novel or is it a crime story? Grouping or clustering, which I mentioned earlier, this takes data and automatically finds groups of similar data points. We can predict if it's going to rain tomorrow or how tomorrow's cricket game will influence our users' track list on our music streaming app. Machine learning can help us recommend products like people similar to you also enjoyed reading this book. And we can even use AI to generate more data. The deep fakes you might have seen, but also generated speech fall into this category. Now, when it comes to our startup, the first thing we want to do is identify good candidates. And I like to think about candidates in 2 general categories. First, is there something that we're doing repeatedly manually that is essential to our business goals and is already generating value? Let's say we're a support center and we choose what blog article we want to send in response to a query. We are doing this manually at the moment. But if we record this data, then over time, the response could be machine learned and automated. Another candidate is the exact opposite. Is there something we're currently doing in code, or maybe not doing at all, that an expert could do or could do much better than us? Here again, this is something where we could use AI to enhance our product. So let's go back to our 1 startups from earlier. Netflix uses machine learning to recommend movies to us. Duolingo's text-to-speech and voice recognition functionalities are machine learning powered. And Lyft manages their fleet using machine learning by predicting where resources will be needed and when. Okay, we've got a good understanding of why to use ML and maybe even gotten a few ideas of how to use it. We've probably all heard that data is the next oil. And we already know that more data is better. But that doesn't necessarily mean that we should keep all data we can possibly collect. So in this next bit, we'll try to find out which data is worth spending time on and money. To think about whether something is worth storing, let's briefly have a look at what steps we'll need to take to get the data to a point where we can train a machine learning model. And let's do so keeping 3 things in mind: skills, cost, and time commitment. First, we need to write software to collect and store the data. The next step is to clean the data. We need to decide what to do about missing or noisy values and outliers, and consolidate data that comes in different formats. Then we'll transform the data to fit whatever it is we want to do or predict. We might even want to enhance it with more data sources or create derived information, and if possible, we will want to label the data. So all this needs to happen before we can even start thinking about training a model. And all these steps cost time and money, time we could spend on building other features of our product. So here are a few questions we should ask ourselves before committing to doing all this work. First, has someone else done it, or could someone else do the task we would want to use our data for? To answer this, let's have a look at how special our data is. A lot of data we could collect and store might be something someone else has specialized on. Some more obvious examples are weather data or stock data, but there are also more specialized data sets that have been cleaned and labeled, like health records or movie reviews. Before storing our data, we should have a look at whether an available data set already meets our needs. There is a lot of open source data, and we can also have a look at the AWS Data Exchange for curated and cleaned data sets we can purchase. The second thing to consider is how common our task is. Chances are that if many companies do it, there's already a service for it. And if there is, it will be likely that it's trained on more data that we could possibly collect right now. Higher level services are also great for building MVPs to estimate the impact machine learning can have on our company. On AWS, we have a number of these services that let you perform the most common machine learning tasks. The AWS Marketplace is also a good place to look for a full ML solution. If there is something that's special about our data, though, none of this will be available to us. So what now? The next question to ask ourselves is how relevant the data is to us. Is this data that has the potential to influence the direction of our startup, or is this just data that's nice to have? If it's not core to our business, but it might be later, let's make sure that we have best practices in place when we collect it, and provide any future data scientists we might hire with the data that will make them happy too. So for now, we'll only focus on collecting and storing while doing minimal cleaning along the way. The first thing we want to do with the data that we collect is to ensure that at some stage different data points from different sources can be linked back together. And we can do this by making sure that we use IDs like unique customer IDs and timestamps. If we can impose a structure on our data, that will make life much easier later on as well. I've seen projects collect data on Excel spreadsheets or as free text. One example I've come across is an application where vets had to give a pet a weight score. And while the field was always called the same, the values were entered as free text. Across clinics, this led to vets inputting integers, fractions, and even strings, normalized and not normalized values, which made the data almost impossible to work with. So if you can impose a scheme rather than having the user infer one, try doing that. With any personal data as well as payment or health data, we want to make sure that we are particularly careful. A great way to provide linkability while taking care of privacy is to just hash these values. A thing that might seem obvious is that we should document everything, where the data is, what the fields mean. This doesn't have to be sophisticated, but it should be somewhere. And I can't stress enough how important this is. I've worked in projects where the initial team had left or had simply forgotten what column headings had meant at the time of data collection. In the best case, it took days to find the right person to talk to. Lastly, we can set a time, maybe just once a year, where we reassess if we still think this data is going to be useful one day, or if it maybe even deserves a little bit more attention. Amazon S3 Glacier is Amazon's object storage solution for archival data and a perfect target for any data we're not currently using. If we're still using the data, moving it simply to S3 is also a great option. If we stash this data away on S3 or S3 Glacier, keeping it won't cost us much. And if we decide that we don't need it or want it anymore, maybe we can create some additional income by selling it, or we could contribute it to the open source or research community. Now I mentioned standardization of data. Let me just quickly give you some tips that will make any data scientist as well as any downstream analytics and ML service efficient and happy. If we deal with media files, the quickest way to make sure that all information is available is to store it in the path directly. This information is easy to parse in an automated way. And using the path to store information on S3 also helps with performance. Alternatively, you can use custom or inbuilt metadata tags. Last modified date and file type, for example, are stored automatically as metadata with S3. But you can add your own and make sure that you have all information available. When in doubt, however, use the path for anything that you want to query on, since that's the most readily supported. Now, most downstream ML services, as well as data scientists, work well with columnar data. The standard way of storing such data are comma-separated value files, CSVs, or Parquet format. The story of the inconsistent data I mentioned earlier could have been prevented just by forcing a particular range and type in the front end. Similarly, consistent column names, especially those that don't contain spaces or special characters, are the easiest to use and most universally accepted by programming tools. This is an example of some nice data. In the data science space, the best data is so-called tidy data. And tidy data follows a few basic principles. There's one column per variable. There is one row per observation, which is often collected at a particular point in time. And each field is one value. Many data science tools assume this format and cater to it directly, which speeds up exploring, visualization, and modeling of the data. And we do want to make sure that if we make the effort and spend the money and time to store the data, it's in a good shape when we need it. Now, what about data that we know is going to be important? Here we want to be a little bit more careful to make sure that we have everything in place. And we might want to go one step further and we'll collect and store and clean, but also enhance the data along the way if we can. One way that will pay off when we want to use the data for machine learning is to make sure that our data is labeled. Now, what does that mean? In the case of our table just before, maybe we can ask the vet to tell us if the weight is in a healthy range, if this is likely to be of interest or something the vet is assessing anyway. Similarly, a diagnosis column could be added. And if you recall, labeled data is almost always better than unlabeled data. Remember when Facebook asked us to tag our friends? What they were doing was collecting input for a feature that now automatically recognizes who's who. Similarly, CAPTCHA is making us label data for them. So building this capability into our application early on can save a lot of work at a later point in time. We can ask our users to rate responses or recommendations they got from our system, or simply make sure that we collect and link manual processes if these are processes that we are following right now. Obviously, everything I mentioned before still applies. This data we can also store on S3 Glacier for later on, but if we're currently using this data, which is likely if it's core to our business, we can store it on S3 directly. To summarize everything I just said, here's how I like to think of data. Is the data I have unique, or how easy is it to collect for anyone but me? And is the data I have relevant to me now, or likely to be in the future? And this one is really linked to the value proposition of my startup. Now, there are two obvious quadrants. There is the data that's not relevant and easy to collect by anyone, and we can throw that out. And then there's the data that's relevant to us and unique. Clearly, we want to keep and prioritize this. Data that's unique but not relevant right now might not need quite as much attention, but we still want to follow best practices when storing it for later. And lastly, the data that is not unique but relevant, we only want to pay attention to if there's no easy way around it, like a data set we can purchase or a high-level service. Let's look at a simple example. We've got a reimbursement platform where employees can upload receipts of their purchases. They then enter values and dates manually and submit the entry to staff that will either approve or decline reimbursement. So we have the receipts, the manually entered values, some metadata, and the status of the claim. We instantly have two good candidates for machine learning. Given that users are labeling data for us by entering the values we can find on the receipt images manually, we can build a model that extracts amount and date directly from the image. The second set of labeled data we have available is which claims are approved and which are declined by reviewers. Over time, we should be able to automate this function too. So which one should we focus on? Well, is there a service for either of these? It turns out there is. Extracting values from images is a common task, so there is no need for us to train our own custom model. And it's likely that someone else is focusing all their attention on this and is therefore doing a much better job than we will, while we are focusing on our core business. The status of a particular claim, though, is something that will be unique to each business. If we want to automate this at some point, that's the data we want to keep and make sure that we label values with a claim status. The metadata might be useful to train a better model too, or maybe it will help us find fraudulent cases. So let's keep that and store it for later. From a data science perspective, I toss out the images, but in this case, we probably need to keep these for audit purposes. Now, just one word on the cost. Simply by moving data that we don't need anymore from a database to S3, we can save up to 75% of the cost. We could even think about making S3 our primary data store and only moving hot data, so data we need a lot and at the lowest latency, to a database. By further moving data to S3 Glacier, which has an optimized price point for archival storage for data that's accessed only rarely, we can save an additional 84%. And you can set up the transitions between S3 and S3 Glacier automatically using lifecycle policies. Let's say we move 1 terabyte of data of our database. Moving this data from Aurora to Glacier will reduce the price from $100 per month to just $4 a month. Triaging data and maintaining good data hygiene is almost priceless, as it ensures that the data is usable in the first place. This also leads to more efficient, effective, and happier data scientists. I also promised an outlook. So where's this going? I've been bringing S3 up a lot throughout this talk, and that's not just because it's really cost-effective storage. S3 is inherently elastic, replicated across availability zones, which also contributes to high durability. S3 is secure by default, and it's really easy to encrypt the data we store on S3. It's also incredibly versatile, and it integrates with migration tools, query tools, and last but not least, all machine learning services on AWS, whether you use high-level services or you build your own models. Let's have a quick look at the different layers it integrates with, from do-it-yourself machine learning to higher-level services. Higher-level machine learning services that connect to S3 reach from text extraction, document and image analysis, over text to speech and speech to text, all the way to automatic forecasts of whatever variable you want to predict. These are services we want to use in the case where we don't need to collect our own long-term data for custom machine learning models, but also for a quick POC that helps us estimate an ROI and prioritize projects. If we already have our own, but so far unlabeled data and decide we want to use supervised machine learning mechanisms, or what I earlier called learning by example, we can label data using SageMaker Ground Truth, a service that allows us to outsource the labeling to colleagues or paid individuals. And lastly, S3 also integrates directly with SageMaker, which allows data scientists to develop custom models from our data in an environment they know, and deploy them as API endpoints we can use in our production system. And here's what such a production system might look like. We use the data we store in S3 as a source. If we don't want to manually create a schema, we can then use a service called AWS Glue to crawl the data and automatically create a data catalog. This is made easier if we used a clear partitioning scheme early on and made sure that we use CSV or Parquet format. The data catalog can then be used by Athena, which allows us to write SQL queries on the data that sits in our S3 buckets. All of this is serverless and scales on demand. Together, these services let us transform the data into a format suitable to the problem we want to solve. Being able to do these transformations at the time we need them means that we can look at the data through different lenses, but it also means that we don't need to know 100% right now what machine learning question we might want to answer later on. We store this transformed data in an additional bucket that becomes the source for our machine learning services, whether low-level like SageMaker or higher-level service. Higher-level services expose API endpoints we can use straight up. But if we make our own model, we can easily deploy an API endpoint that can then be used through a Lambda function and API gateway. We leave the implementation of such a pipeline until we have time to focus more attention on AI. But let's quickly recap a few things we can do right now to make sure that we don't accidentally throw away valuable data, but also not spend too much time and money on data we may never need or use. Take stock of your data and classify if it's relevant and unique. Then clean out everything that's neither and migrate currently unused data to cheaper storage. For the most valuable data, take some time to create a strategy and think about easy ways to clean and enrich the data along the way, and make sure that the data you do keep is documented and as clean as possible. If you think machine learning is on the horizon and need additional advice, please reach out to your account team or visit aws.amazon.com/machine-learning/learn to learn more about how to get started. Lastly, I want to leave you with a few tips that make sure that your time on machine learning projects is well spent. Pick a problem that has high potential impact and a good chance of a high ROI. We also need to make sure that we know exactly what defines success and that that's measurable. One thing that can happen when working with data scientists is that we prefer to do things from scratch. But using a higher level service when possible will get you to an MVP quicker, which allows us to get an estimate of the possible impact before committing fully to a particular project. Some of these higher level services even allow us to fine-tune models to our own data. And we can always build a custom model later on when we know that this will be worth our time. And lastly, we need to make sure that there is a direct path to production and buy-in for the particular machine learning product. Without that, all our efforts were a waste of time, money, and skills. And speaking of skills, you joined the AWS Summit to learn, and you can keep the learning going after the summit with resources from AWS training and certification. There are over 65 courses, and many are available for free and on demand. AWS experts will help you and your team learn to apply ML to your business. And when you're ready, you can even take the AWS Certified Machine Learning Specialty Exam, which validates your skills and provides an industry-recognized credential. For more information on that, go to aws.training/machine learning and have a look at our ramp-up guides. And for now, I'd like to leave you with this quote from Marissa Mayer, a founder herself and an investor. With data collection, the sooner the better is always the best answer. Thank you. I hope you enjoy the rest of the summit. And if you like, please take the time to complete the session survey.